Hello and welcome to another video. In this video we're going to be doing another easy problem, maximum product of two elements in an array. And it's basically asking you, given an array, pick two numbers, the two biggest numbers, and multiply them, but before you multiply them, subtract 1 from each one. So like here it'll be 4 minus 1 times 5 minus 1, then we will get 12, then here we get 5 minus 1 times 5 minus 1, 16, then we will get 2 times 6, 12, and so on. There's kind of two ways of doing this. Obviously, there's like some brute force stuff. There's like a bunch of, I guess there's like a billion ways of doing this. But kind of the two ways that I think are pretty reasonable are one, and we'll go over both of them briefly. One, keep track of biggest number, and second biggest. And the other way is a heap. There are a bunch more ways, but these two I think are pretty good, and they're basically O of n, because heap pushes and heap pops in a heap are typically log n, but because you have log 2, it's basically linear time, right? You're gonna have a heap of like 2 items, so it'll be constant time operations. So let's go over both of these kind of and how they would work. So the first one, if you have this array of some numbers, essentially we're gonna have a 1 called our biggest number and 2 called the smallest number. We're going to initialize them both to negative infinity, and we will just loop through our array, and we'll have some conditions. So the first condition is if our number is greater than our biggest number, then we want to replace the biggest number with that number. But we also, what we have to do is we also have to actually, before we do that, we have to replace the second biggest number by the biggest number. So we can write that down. So if num is greater than 1 here, or biggest, then replace second with biggest, and replace biggest with num. And the other condition is if num, so if the first one isn't true, if num is greater than the smallest one, or the second one, then just replace second with num. And the reason you have to replace both is because let's say our numbers are like this. So let's say we have like 5 and 3. And we reach 9, right? 5 is our biggest, 3 is our second biggest, and we reach 9. We can't just like replace this 5 with the 9 because we actually need we need to store the second biggest number as well. So we would replace this 3 with a 5 as well. Let's kind of walk through the array with that algorithm. And like I said, let's just start off with these negative infinity and see how that would work. So we reach a 5. So this is bigger than our biggest, so we would replace the smallest with our biggest, but they're the same. Then we would replace this with a 5. Now we reach a 9, so this is bigger than our biggest, so we'd have to replace the second biggest with our 5, and our biggest would be a 9. Then we reach a 1, which is neither of the cases. We reach a 2, neither of the cases. We reach a 9. It's not greater than the biggest, but it's greater than the second biggest, so we would replace this with a 9. Then 11 is greater than our biggest, so we would replace that. And before doing that, we would replace the second biggest with the biggest, but they were the same. 3, don't care. 5, don't care. 8, don't care. 13, replace 9 with 11, and replace the biggest with 13. And these are two elements, then we just subtract 1 from each and multiply them. That's the first way, and that does work. Now, min heap I think is actually a little bit easier, and essentially what we can do is for a min heap, we're just going to have a heap of two elements, and remember they're going to have the min element here and the max element here. We'll make them both negative infinity as well. And now essentially all we need to do is just go through, and if an element is bigger than our smallest item, then we will kick out the smallest item and replace it by that element. So like here, we will loop through here. 5 is bigger than our smallest item, so goodbye that one. Replace it with 5. Now negative infinity is our smallest item, so we have 5, or we have a negative infinity and 5. Now we reach a 9. That's bigger than our smallest item, so goodbye that item. Now 5 is our smallest item, so 5, 9, 1, don't need to do anything, don't need to do anything. 9, replace the 5 with a 9, now we have 2 9s. 11 is bigger than our smallest item, so we will replace the 9 with an 11. Now 9 is our smallest item. 3, don't need to do anything. 5, don't need to do anything. 8, don't need to do anything. And 13, we will replace the 9 with a 13, and now 11 is your smallest item. So essentially, we can write this down as well. If num is greater than heap 0, right, the smallest number, then kick heap 0, and heap push num. And like I said, a heap pop and a heap push in a heap of length 2 will be pretty much constant time. So this is another way to do it, and I think it makes a lot of sense. And this is like a generic way, like let's say instead of asking for the 2 biggest numbers, you're asked for the k biggest numbers. Then you could make a heap of length k, and then this will always work, right? So if you're asked for like the 4 biggest numbers, you would have a heap of length 4, and then you would just do that, right? So the idea is at the end, because you have a min heap, you're basically kicking out the smallest number for anything bigger, and then you're going to have the 4 biggest numbers at the end. So we will actually just code up this heap solution because I think it's a little bit easier, but either one of these is fine. Keep track of one or both is fine, and then this is also fine. The other things you could do is you could like loop through your array and find the biggest number, right? Just do max, and then get index of max, so you'll get some index over here. And then you can just like manually loop through your array again and look for the max that doesn't have this index. So find the biggest number that doesn't have this index, or alternatively slice your array or something where you just get the max of whatever the array is except for that index. So a bunch of different ways, but basically there's like a billion ways to get an O(n) solution here. So let's code this one up with a heap. So we're going to make a heap. It's going to have 2 items, right? So we're just going to have, you could have an empty heap, but I'll just have 2 items of both of them being this. And now we can just loop through our numbers. So we can say for num in nums, if num is greater than heap 0, kick out heap 0, replace it with num. So heap pop heap, and heap push heap num. And finally, we'll have our 2 numbers. I think we need to do this. We'll have our 2 numbers. Now all we have to do is take them and subtract 1 from each one. So we could return heap 0 minus 1 times heap 1 minus 1. And we can just do a parentheses here, and that should do it. So let's take a look. Heap is kind of like, obviously if you're doing easy problems, probably have some kind of error. Let's see. Curious what it is though. All right, we don't have an equals. Heap is kind of like an overkill for easy problems, but just wanted to show you guys like another way you could do it if you want to. You could also have the smallest and biggest, or like 50 other ways, to be honest. But it's quite convenient for the general case, and you could see it's still pretty fast. So if you look at my actual submissions, this is with a heap, and this is with without a heap. So if you just like submit a bunch of times, they're basically the same. Yeah, so like I said, this is going to be O of n, because even though we are heap pushing and heap hopping, we are heap pushing and heap hopping from a constant number, so it's always going to be like log 2, which is a constant number. And yeah, and then also for the time, or for the space, it's just a heap with 2 items, so it's basically of 1 again, so that's why it doesn't really matter that we use extra stuff. Yeah, so hopefully you enjoyed this one, another pretty easy one. Looking forward to more easy problems. So if you did like this video, please like it, and please subscribe to the channel, and I'll see you in the next one. Thanks for watching.